Welcome to today's Explainer. Today we're going to do something pretty cool. We're going to mentally deconstruct our entire planet to truly understand its absolute deepest foundation. You know, we build our whole lives right on top of the Earth's surface, but what if we just stripped all that away? If we took away the oceans, the soil, the vegetation, what's left? We're going to look right at the true, fundamental building blocks of our world.
To really get a grip on this, let's start with something familiar. Imagine you're building a house. How do you actually start? Think about the process for a second. You don't just order one giant house-shaped block of material and drop it onto a plot of land, right? Complex structures simply aren't built that way. Instead, you build them using much smaller, manageable components.
And that brings us to a really major concept here. Just as a house is built by stacking individual bricks to create your walls and your foundation, the Earth is built in the exact same way. Our planet isn't just one giant solid mass of generic rock floating in space. Instead of bricks, the Earth is built from minerals. Minerals are the ultimate building blocks. They build the rocks, and then those rocks build the Earth's crust. So when we talk about mineralogy, we're really just talking about the study of these natural building blocks of our planet.
So Section 1, what makes a mineral? We're going to look at the strict 5-rule definition of a natural building block.
Not just any random stone you pick up off the ground makes the cut. For a material to be officially recognized as a true mineral, it absolutely must satisfy these 5 highly specific conditions. First off, it's got to be naturally occurring, so no lab-created materials allowed here. Second, it has to be inorganic, meaning it doesn't come from living matter. Third, it's got to be a solid. Fourth, it needs a definite chemical composition, like an exact recipe of elements. And fifth, it must have an ordered crystal structure, meaning its atoms form a highly specific repeating pattern. So the crucial takeaway here is this: if even a single one of these 5 conditions is missing, it simply isn't a mineral. But when all 5 align, you get nature's perfectly manufactured materials.
Moving to Section 2, baking rocks from minerals. This is the cake analogy of geology.
Okay, let's dive into this, because honestly, this is where geology really comes to life. A cake isn't just a single ingredient, right? It's flour, plus sugar, plus eggs, all baked together. Well, a rock works the exact same way. Take granite, for example. It's one of the most common rocks on Earth, but it's really just a combination of quartz, feldspar, and mica, all mixed together. Just like baking a cake, when nature mixes these specific mineral ingredients together under the right heat and pressure conditions, boom, you get a rock.
Section 3. How geologists identify minerals. Basically, solving the geological puzzle.
Now that we know what minerals are, how do scientists actually tell them all apart? Because there are a lot of them. Geologists don't just look at a rock and make a wild guess. They have to act like detectives, testing minerals using a very specific set of physical properties. They look at luster, which is how the mineral reflects light. They look at color, obviously, but they also look at streak, which is kind of cool. It's the color the mineral leaves behind when you crush it into a powder. They test hardness using the Mohs hardness scale. They look at cleavage and fracture to see exactly how the mineral breaks apart. And they measure specific gravity to figure out its density. Every single one of these properties gives geologists another vital clue. It's literally another piece of the puzzle to accurately identify exactly which of nature's building blocks they're holding.
Section 4. The secret is in atoms. This explains why minerals behave completely differently.
To truly understand why minerals have all these different physical properties we just talked about, we have to zoom way in. At the microscopic level, everything comes down to atoms. The reason minerals look, feel, and behave so differently is because they have different chemical compositions, or they have completely different atomic arrangements. It's literally the architecture of these atoms that dictates everything about a mineral's identity. And honestly, this leads to one of the most fascinating phenomena in all of science. Even the exact same chemical element can form entirely different minerals.
Now, what's really interesting about this slide is the sheer contrast between a diamond, famous for being an incredibly hard, dazzling gemstone, and graphite, the super soft, dark material inside the pencil you use to jot down notes. The crazy fact here is that both of these are made of the exact same element, 100% carbon. No difference. It is strictly their atomic arrangement that makes the difference. Nature took the exact same ingredient, arranged the atoms a little differently, and created entirely different properties. That one tiny tweak gives us both the hardest natural substance on Earth and pencil lead. How wild is that?
Bringing us to Section 5, why minerals matter every day. They are the invisible building blocks of modern civilization.
It's so easy to think of mineralogy as just this ancient, dusty science of rocks, but its impact is happening all around you, right at this very second. Minerals are absolutely everywhere. They are the vital components inside the smartphones we use to communicate. They are the structural foundation of the buildings we live and work in. They're in the cars we drive, the systems that generate our electricity, the medicines that keep us healthy, and yeah, of course, the jewelry we wear. Our entire modern civilization is utterly and completely dependent on minerals. They aren't just sitting buried in the ground. They are completely integrated into almost every single tool and convenience we rely on to function as a society.
So, to kind of bring this all together, mineralogy isn't just about categorizing pretty stones. It's the comprehensive science of understanding what minerals are, how they beautifully and naturally form over vast amounts of time, the detective work of how to identify them, and most crucially, why they are so deeply important to our survival and progress. Think of it as the ultimate user manual for the materials that make up our world.
Because think about the massive stakes here. If we were to somehow magic away all the minerals from existence, we wouldn't just lose a few pretty crystals. Actually, scratch that. It's way bigger than that. There would be no rocks. Without rocks, there would be no mountains, no land masses or landscapes as we know them. But even beyond nature, there would be zero technology. The screens, the batteries, the copper wires, all gone. There would simply be no modern civilization.
As we wrap up this explainer, I really want to leave you with this thought. Every mountain, every building, and even the phone in your hand begins with a mineral. Mineralogy helps us understand the tiny natural building blocks that make our world possible. So the next time you pick up your smartphone or look out at a city skyline or admire a towering mountain range, I want you to ask yourself, what other incredible things in your immediate surroundings are really just a hidden combination of nature's perfectly arranged minerals? Keep exploring, keep questioning, and I'll see you next time.